Hey guys, if you're watching this, means little isosceles Grigsby's been born, and probably elbows deep in dirty diapers and running on about 30 minutes of sleep, so it can always be worse. But I'm gonna record these videos here. I don't know how many I'm gonna record. Try to do the best I can to keep you guys learning when I'm not here. So I'm gonna record these videos. Like I said, I don't know where exactly we're gonna be. Right now I'm recording this on February 23rd. So I'm just guessing right now as to where you guys will be. I'm guessing I'm gonna just gonna go with chapter 10 and see where that takes us. See how many videos I can make. I can't guarantee I'm gonna make all the videos on all the lessons that I'm gonna teach. So that means you guys are gonna have to do a lot of work. You can pause these videos if you need to stop anything. I'm gonna leave some spaces where I'll have whoever my substitute is. Let them pause and let you guys try to figure some things out. You have to do a lot of work outside of class, inside of class. It's gonna take some work. So let me just go ahead and get started here. And so I'm gonna, like I said, chapter 10 it deals with circles. So that's what we'll talk about first. So here we go. Here goes nothing. So first of all, a circle. There it is. That's what a circle is. But what I want you guys to do is just think about this. What do you think would be the definition of a circle? So first thing, I'm just going to guess what you guys are thinking about a circle. I get this a lot when I've asked this question before. A lot of people say it's round. That's true. It's round. But I mean, if you just look at a figure like this, that's round. So that's not quite a circle. Hopefully everybody's aware of that. It's more ovalish. Might think one of the things you might think was maybe it doesn't have any sides. Well, what I just drew doesn't have any sides, and that's not a circle. It's not a polygon. It doesn't have any sides. Doesn't have any angles. Not any vertices, at least. That's what I meant. We're going to talk about different angles inside of circles eventually. But so what I'm going to do is I'll just go ahead and give you the definition. You might already have it. You might have already said it. But the definition of a circle. Well, first of all, all circles have a center, some point. I'm just going to guess where the center is. Let's say that's the center of this circle. So that's the center. Now, one thing I want to talk about here is you guys, I'm sure you guys know a little bit about circles. You guys have been, even in kindergarten, they teach you what shape is a circle. So radius, I know you guys have heard that term before. I've used it before. This circle has a radius, so let's say this is the radius here. Now, I'm trying to get to the definition here. So we've got this radius, and what I'm trying to say here is, well, we have multiple radii. Okay, so that could be a radius. This could be a radius. So the question I'm going to ask is, does the radius of a circle, again, I'm not changing the size of the circle, so I don't change the size, is the radius ever going to change? Is there going to be any difference between any of these measurements? And hopefully you guys know the answer is no. The radius is always the same. So the definition of a circle is that it's the set of points that are equidistant from this given point. All right, so all of these points on the circle, these are points on the circle. All right, this would be a point inside the circle. This would be a point outside the circle. Okay, so all these points on the circle are going to be the same distance away. They're going to be the radius away from the center of the circle. So let's go ahead and write that down. I've got you some guided notes, and I'm going to try to give you as many guided notes as I can. And by the way, if you couldn't tell, this is the first video I'm making, so I may have to adjust. I might have to do a video earlier or a video later, depending on when my wife decides to go into labor. So I have no idea when that's going to happen. So I know March 20th is the due date, so we'll see if that's close. But anyway, so this is chapter 10. We're going to talk about circles in this entire chapter, right? That's the main concept. Properties of circles. That's the chapter name. And so the definition, I've already talked about it. A circle is the set of all points in a plane that are equidistant from a given point. And that given point is going to be the center of our circle. All right. So I just want to warn you guys, I've got some guided notes there for you. And it's got two circles on it. Don't draw anything, and hopefully you already haven't. All right, don't draw anything on those two circles. We're going to add to this. We're going to define these other terms on those two circles. All right, so don't draw anything there. So, like I was mentioning earlier, this is what I was trying to draw here. This is what I drew earlier. All these, I drew 3 different radii here. And all those points are going to be, whatever the radius is, that length away from the center. So all these points are going to be equidistant from the center of the circle. Now notice one more thing I want to point out. It has to be in a plane. So remember, plane is 2-dimensional. So what I want you guys to think about is this. If I went 3 dimensions here, and let's say I didn't make this distinction. Let's say I didn't say anything about it being in a plane. What would be the set of all points that are equidistant from a given point, maybe in 3-dimensional space? Think about that. Let me say that again. Let me say that again. Okay. Well, what is the term for the set of all points equidistant from a given point in 3 dimensions? Let you think about it. Okay. Stop thinking. It's called a sphere. Hopefully somebody said it. If you guys said it, nice job. All right. So there we go. That's what a circle is. So it's important to know the definition. I ask this all the time. A lot of people can, like I said, they give me the characteristics. Yeah, it's round. Yes, it doesn't have any vertices. Doesn't have any sides. But that is the textbook definition of what a circle is. All right, so guys, I'm just going to, again, just warning you, this section right here is a lot of terminology. You need to know what these terms are before we can move on. I'm going to refer to these terms a lot. So let's go ahead and get this thing rolling. So if you notice on your guided notes, your first term is radius. Okay, well that's nothing new. We've already mentioned it here before we got started. So what a radius is, it's a segment whose endpoints are the center and any point on the circle. So that's all there is to it. So we go back, I'll flip back here real quick. Center, endpoint on the circle, that's a radius. Okay. A chord is probably a term that you guys haven't heard before. Well, you might have. In terms of circles. So what a chord is, it's a segment whose endpoints are on the circle. So guys, we'll draw this in a second, but just get this down for right now. And the diameter of a circle, you guys should know what the diameter is. It's nothing new. It's a segment that contains the center of the circle. Yeah, the segment contains the center of the circle. So let's go ahead and, like I said, this will be on the first circle that I have. Try to draw these. Again, label them. This guy right here, nothing new. That's the diameter. It goes through the center. Any segment that goes through the center. I'm gonna change this up, guys. I made a small mistake, so fix this. I apologize if you guys have already written this down. Rather than saying a segment, let's use the term we just defined here. It's a chord that contains the center of the circle. So a diameter, all it is a special type of chord. And by chord, we know that it has endpoints on the circle. Alright, so I went ahead and drew a chord as well. So guys, this is just a generic chord. Like I said, this is a specific chord. It's called the diameter. It goes through the center. Alright, but we could draw as many chords as we want here. Let's just draw one so we know what we're talking about. So any segment that has endpoints on the circle is a chord. That's all there is to it. Alright, so guys, I'm going to keep moving quickly. I don't want this video to be 50 minutes long or anything like that. If you ever need to pause, just let my substitute know, and I'm sure they'd be more than happy to do that. So let's keep going. Next thing, there's 2 more terms I want to talk about, and those are secant and tangent. So let's try to write this down. A secant is a line that intersects a circle in 2 points. A tangent is a line in the plane of a circle that intersects in exactly 1 point. Alright, so it's got to be on the same plane, that's all we're saying. So it's still 2 dimensions that we're talking about. Alright, so right here I've got these 2 drawn. So hopefully you guys have written that down in your guided notes. hopefully you recognize there's a big difference between the two. Obviously, this is a secant because it intersects the circle at 2 points. Right here and there. 2 points. 1, 2. A tangent line, the reason why it's called a tangent, I'm not sure what language it comes from, where the word is derived from, what the origin is. But tangent, in another language, it means to touch. All right, hopefully that makes sense. This line is just going to touch that circle and not go through it. Secant comes from a root word meaning to cut. So it cuts the circle. It goes through the circle. All right, so that's how you can remember secant and tangent. Another thing I just want to point out real quick. A lot of people get confused on what a tangent is. I know I've just defined it, but a lot of people think this might be a tangent. Let me just draw an example here just so you guys don't make this mistake. So that right there, that is not a tangent. Let me explain why. Because first of all, that's a ray. It's not a line. All right, so this is a ray. It has an endpoint on the circle and it goes out. And second of all, if I were to extend this, obviously, guys, if I extended this, it would go through 2 points. So if I extended that line, that's actually a secant. All right, so that's not a tangent. A tangent looks like this. It's just going to barely touch the circle at 1 point, and then it's going to move on. It's not going to go through the circle at all. If I extend it, it's still not going to go through the circle. Okay, so that's what a tangent is. Hopefully, that's all right. And guys, if you have any questions, I'm sorry, you're gonna have to do the best you can. I'm not there to help you. I might try to, might is the key word. I might try to maybe do some video chats, maybe once a week, maybe. I'm planning on being out for about a month, so yeah, you'll have. I know you guys were thinking when I told you guys my wife was gonna have a baby. And you're thinking, oh yeah, we're not gonna do anything now. We're gonna hang out for a month. That is incorrect. We're still gonna work. All right. So here we go. Let's keep going. So that's the tangent. I'm not sure what I was going with this. I'm gonna skip this. All right. So let's just look at an example. We're just gonna label it. I'm gonna let you guys do this. So my substitute, pause this please, and let everybody work on this. Let me scroll down so you guys can see it. I've got the directions written down. There's all the stuff. So go ahead and pause it, and I'll write the answers in a second. Okay, here's the answers. So segment AC is going to be, it wants us to label it as a radius, chord, diameter, secant, or tangent of a circle. So what term best describes that? And hopefully you guys got AC to be a radius. All right, its endpoints are the center and an endpoint on the circle. Okay. Segment AB. Well, hopefully you guys got, well, there's two things we could call that. It is a chord, but it's a more specific chord, so it is a diameter. It goes through the center. All right, ray DE is going to be, hopefully you guys got that this is a tangent line, or tangent ray. Rays can be tangent as well. And then line AE is, hopefully you guys got secant. Now, a common mistake that people make is they mix up a secant and a chord. That's a common mistake. Guys, a secant is a line that's going to keep going. If we talked about just the segment from A to G, that's going to be a chord. All right? But if you extend that and talk about a line, that's a secant. So secants and chords are very similar. There's not a whole lot of difference. A chord has endpoints on the circle, a secant doesn't. So that's the difference. All right? So that's pretty much it for that problem. All right, let's keep going. Next thing, let's talk about coplanar circles. So, coplanar circles. First of all, the first bullet here, the first fact you need to know is two circles can intersect in 3 different ways. They can intersect in 2 points, they can intersect in 1 point, or they can intersect in no points. All right, so they might not intersect at all, so that would be no points. Coplanar circles that intersect in 1 point are called, you might be able to guess this, a line that intersects a circle at 1 point is called a tangent line. So circles that intersect each other at 1 point are called tangent circles. Okay? The last bullet, coplanar circles that have a common center are called, well, common center, this is the term here, concentric. Concentric circles. Now right now the Olympics are going on. I've been watching. Anybody been watching curling? Can't get enough of that stuff. So if you watch curling, the target that they're, I don't even know what you call it, I'm not an expert, but the target that they're shooting for, that they're curling at, is circles that have the same center. Right? There's rings of circles. So something like this. I don't know, let me draw it real quick. Well, that's terrible. But we'll call that a circle. We'll call that a circle. I don't know how many, I think there's 3. So those are concentric circles. They've got the same center. Right? They don't intersect each other, but they have the same center. All right, and I'll draw that again when I talk about, we're going to draw a picture of this. All right, so that's the next thing. Left you some room, draw a picture. So let's keep going. So, like I said, there's 3 different ways that circles can intersect. They can intersect at 2 points. This is how you draw this. There. There. Okay. Those are the 2 points where they're intersecting. So draw something like that. 1 point of intersection. There's a couple different ways that we can have 1 point of intersection. Let me show you a couple different ways here. It could look like this. Okay, hopefully you guys can see that on the, something like that. The only point they would be intersecting would be right here. What else could happen is we could have this circle kind of be inside of the other circle, but still intersecting it. So let me draw that real quick. I'm going to scroll down just a tad. So we can have a circle here, and then I'm going to draw a circle inside of it. Those aren't concentric because they don't have the same center. But yeah, they're the ones inside of it, and it's only touching at one place. Concentric circles are never going to intersect, and I'm going to draw that in a second. So yeah, those would be different ways that you could have 1 point of intersection. And then the last thing, obviously guys, I mean this one's not too hard to draw. 0 points of intersection. Those circles aren't intersecting. And neither are these. Concentric circles like I talked about earlier. Circles with the same center, those aren't going to be intersecting either. Alright, so hopefully that's clear. Those are the only ways that circles can intersect. 2 points, 1 point, or no point. And this would be non-intersecting at all. Okay. Alright, I'm going to keep rolling. Common tangents. So here's the definition of common tangents. So we'll unpack this in a second. A line, ray, or segment that is tangent to 2 coplanar circles is called a common tangent. So it's one line that's tangent to 2 circles. So let me draw this. I'm going to draw an example of one, and then I want you guys to think about how many you could possibly draw in this scenario. Okay? So let's go ahead and do that. One of them will look like this. I've got to get my marker out. So let's say that's a point of tangency. Let's say this one as well. If I can try to draw it, they're kind of hard to draw sometimes. It's hard to draw straight lines as well, especially for me. So that right there might be a common tangent. So that's one. That's one common tangent we can draw. So here's what I want you to think about. Just think about how many more can we draw. Alright, well let's keep going. So let's show another one. Well, down here we go to the bottom, right? So hopefully that makes sense. Got this. That would be 2. Now, a lot of people might stop there, but there's actually 2 more. What could happen is we could draw a line down the middle this way or that way, kind of like make an X here. So I don't know where exactly this would be, but I'm just going to do my best here. Yeah, that's not bad. So that might be a common tangent, and this might be a common tangent. So those are the only 4. The answer was 4, by the way. There's only 4 common tangents we can make with those 2 circles. All right. Hopefully that makes sense. Let's keep going. So here's the next example. Now I have the directions written down. I don't have it written on the board right now, but they're on your guided notes. So the directions to the next example, example 2, is tell how many common tangents the circles have and draw them. Or you might want to draw them and then tell. So let's look at this guy. It's not the same answer as the last one because it's different. Our picture's different. There are tangent circles. They're intersecting at that one point. So let's see how many we could draw. Well, hopefully you guys saw. Actually, you guys do this without. So my substitute, if you could pause it here, let the students do this. Pause it right now. All right. So here we go. You would actually, the answer here would be 3. That'd be the answer. The reason is because that would be a common tangent. So with that, and there's one we're missing, I know a lot of people might have put 2. There's actually one you can draw down here. That would be tangent to both of them. So there's 3. Next example, part B. Well, we've kind of already done this one. Actually, no, we haven't. My bad. We have not done this one. So try to do this one. Again, pause it if you need to. Here's the answer. 1, 2, and that's supposed to be tangent. So answer's 2 there. And last one. How many can we draw here? Some people might have said 0. The answer is 1. That's going to be tangent to both of them, isn't it? All right, so there you go. Those are those 3 examples. Okay, let's keep it rolling. I'm going to get to the next theorem here. So guys, really all we've talked about so far are just different facts, different terms. So we're actually going to get to a theorem. A theorem is a fact that you can prove, but we're not going to prove them. We're just going to accept them and move on. So here's the first theorem. In a plane, a line that is tangent to a circle, my bad, I misspoke. Let me read it again. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its end point on the circle. So try to fill in the blanks there, everything we're missing on your guided notes. So I know I didn't leave a whole lot of room to draw the picture, but try to draw this picture off to the side. So what we're saying here is this. I've got a tangent segment to my circle, and so if I were to draw a radius to that point of tangency, and by the way, I didn't talk about that, but this right here is going to be the point of tangency. That's not really a term I defined, but you should know if that comes up, and that should make sense. It's where it's tangent. So that's your point of tangency. And let's say we wanted to draw a radius to that endpoint. So radius always has endpoints from the center to that guy. And hopefully you guys can tell that, yeah, that's going to be a 90-degree angle. Right? Now, like I said, we're not going to prove this, but hopefully it looks like it is. Hopefully you guys can see that, yeah, that's going to be 90 degrees. So yeah, it does have to be 90. It does have to be perpendicular to that point of tangency. Now that's going to be important when we try to find the missing side. So let me show you here. This next example is going to deal with that. So hopefully that makes sense. I'm going to say that a lot. Hopefully that makes sense. I'm hoping. If it doesn't, you can ask a classmate. Again, can't really ask me, but here we go. So here's the example. In the diagram, segment PT is a radius of circle P. Is segment ST tangent to circle P? All right. So let's kind of unpack what that is asking here. So basically, what we're trying to figure out is ST. Is that actually a tangent segment? So if I were to extend that, I know it kind of looks like a tangent segment, but it may not be. All right, we have to check this. So, and I'll talk about how to check it in a second. So what I mean by that is we might not be able to see it, but if we extend it, it might just barely go through the circle like that. All right, it might go through it at 2 different points. All right, now remember, a tangent only intersects the circle at one point. All right, so it could be tangent, it might not be. So what you can do is you can use that last theorem that we just talked about. And what we were trying to figure out, if we can figure out that that's perpendicular, then that has to be a tangent. That's what if and only if means, guys. That you can read it either way. So you can read this as, if a line is tangent to a circle, then the radius drawn to that point of tangency is perpendicular. Or you can read it backwards and say, if the radius drawn to that point of tangency is perpendicular, then it has to be a tangent line. All right, so that's what we're going to do. We're going to read the backwards way here to figure this out. So guys, I'm trying to figure out, is that a right angle? So I'll do that and put a question mark. Is that a right angle? Is this perpendicular? Now this is good review from when we talk about triangles, guys. So look at this. Didn't we just form, isn't that a triangle? So if we just formed a triangle, what we're trying to do is we're trying to test to see if that's a right triangle. If that's a right triangle, then that's got to be perpendicular, and therefore ST has to be a tangent line, okay, or a tangent segment, we should say. So again, let me just slow down here for a second and say we're trying to determine whether or not this is a right angle by determining whether or not this whole thing is a right triangle. Now, if you guys remember, I'm going to ask you guys this, and you can say it out loud if you know it. How do you determine whether a triangle is right? Dramatic pause. All right, you can determine whether it's right if the Pythagorean theorem works. All right, don't forget about the Pythagorean theorem. That's the one theorem you should all know from geometry here. So here we go. So what we have to do is test to see if a squared plus b squared does in fact equal c squared, and if it does, it's going to be a right triangle. So here it goes. Is 12 squared plus 35 squared, is that equal to 37 squared? All right, you have to give me a second. I don't have a calculator handy. I don't know 37 squared off the top of my head. I know you guys do, but I don't. So 12 squared, obviously, yeah, that's 144. 35 squared, 1 minute, 1225. 37 squared, 1369. So if you take 144 plus 1225, enter, 1369. Checks out. So therefore, I know this is a right angle. So therefore, I know this is a right triangle. STP is a right triangle. And so what do I have to know about segment ST? Well, segment ST is a tangent. And you can put is a tangent line, is a tangent segment, whatever. I'll just say segment ST is a tangent. All right, there it goes. Moving on. Again, if you need to rewind, go ahead and do so. Keep going. All right, so here it is. Example 4. Draw this picture. And again, I didn't draw the picture, so that's a good place to pause. There's no picture drawn. Pause the video and let the students draw this. So in the diagram, B is a point of tangency. Find the radius R. Okay. So again, I didn't write the directions down on the board, but they're on your guide notes. So here it goes. So what we're trying to do is, it says in the diagram, B is a point of tangency. Right there. So we know this segment's a tangent segment. Find the radius R. Okay, so again, this is going to piggyback off what we learned about right triangles. Kind of gave it away. What I was going to ask is this. What does that angle have to be? You guys already know it's a right angle. The reason it has to be a right angle is this is a tangent line. This is a radius drawn to that point of tangency. And that theorem that we just looked at, this guy right here, tells us that that has to be perpendicular. That has to be a 90-degree angle. All right, so let's go ahead and get this thing started. So if we've got a right triangle and we want to find a missing side, again, don't forget about what we know about right triangles. You can always use Pythagorean theorem as long as you're not missing too many sides. And you're actually not in this case. So let's talk this through. So here it goes. I want to try to set up Pythagorean theorem. All right, I know this is a right triangle. I can use that to figure out what R is. So what I'm going to do, again, is a squared plus b squared equal to c squared. And the one thing I want you guys to notice is what is your hypotenuse? What is c in this case? Little c, not big C, little c. Your hypotenuse. If you said 50r, that's wrong. It's not 50r, it's 50 plus r. Okay, so make sure you guys are aware of that. So here we go. Let's set this thing up. A and B are going to be the other two sides. So it's going to be 80 squared plus r squared is equal to, parentheses, 50 plus r squared. Alright, so we got a little work to do. Alright, we can talk this through. This is just a little bit of algebra we got to do here. Anyways, 80 squared, I believe, is 6,400 plus r squared, and that's going to equal. Alright, so let's square this guy out. Now, a lot of people are tempted, and this is a common mistake, a lot of people are tempted to just square 50 and to just square r. Can't do that. The reason is we've got a binomial squared. Alright, so this is not 2,500 plus r squared. There's going to be a middle term. So what I mean by that, let me write this out here off to the side. So if we're trying to take 50 plus r squared, what I want you guys to think about is this. What does anything squared mean? It means that times itself, right? So let's take 50 plus r times 50 plus r. That's why I said this is a review of an algebra concept here. So we need to multiply this out. Well, the mnemonic device you guys use, the way to remember this is FOIL. F-O-I-L. F stands for first, so we got to multiply the first ones together. So that'll be 2,500. Then we multiply the outside terms together. The O is outside, so it's going to be 50 times r, which is 50r. Then multiply the inside terms together. R times 50 is still 50r. And then we got to multiply the last terms together. The L, which is F-O-I-L. L is last terms. R times r. R squared. There it is. Now combine like terms before we do anything else. So that's going to be 100r. If we have 50 of those guys plus another 50 of those guys, we got 100 of those guys. Alright, so I did that work off to the side just so we could, just so we could solve this. I didn't have enough room over here. So I'm going to plug this in here now. It's going to be 2,500 plus, shoot, I'm running out of room. That'll be 100r plus r squared. Here, how about, I don't like that. How about I do this? Let me move it down. There it is. Alright, so we got to solve that. Now, I know it might look daunting here, guys. We've got some squared terms. That's alright, you can handle this. Because what happens, we've got an r squared on this side, we've got an r squared on this side, so we can get rid of those. We can get rid of those by doing what? That's right, subtracting. R squared. Cancel on both sides. 6,400 is equal to 2,500 plus 100.